Did you know that the average person produces 4 pounds of trash a day? A family of 4 produces 112 pounds of trash each week. America produces 270 each year. Now that's a problem. Small town of about 4,000 people. Located southwest of Venice, it's primarily agricultural. It collects its municipal solid waste throughout the local region, but instead of dumping it in a landfill, the operation is housed in 2 main buildings. Those 2 large doors open into the waste receiving building. We receive and stage the waste here and prepare it for combustion. Then we convey it into the main building for further processing into a fuel stock. Trucks deliver partially processed municipal solid waste from the surrounding area to the receiving room. This is approximately 80 tons of refuse-derived fuel. The waste here is made up of various materials, including paper, light plastics, heavy plastics, foam, leather, cardboard, cellophane, and other hydrocarbon-based materials. Waste-to-energy fuel is typically prepared by a cleaning and drying process before going into the system for gasification. This facility uses a combination of a front loader and clamshell picker to move the waste material from the staging area onto the conveyor. Other facilities may vary based on the type and condition of the waste fuel energy you want us to generate. Our engineering people carefully evaluate each facility's fuel preparation needs. That ensures consistency, reliability, and efficiency at all stages downstream. Depending on the type of waste, our facilities may also include equipment that conditions the fuel by removing fines such as sand and dirt. We may also need to lower the waste's moisture content before we send it into the thermal combustor. For maximum efficiency and lower maintenance cost, all the waste fuel stocks must meet our specifications, and we know how to do it. This conveyor moves the fuel into position for densification. The densification equipment is the large green and yellow wheel-shaped machinery. Using both pressure and heat, this equipment compresses the fuel. Then the screw conveyor moves it into the densification chamber, where it is then compressed and pushed into one of the 80 conical densification dies. As the densified material comes out of these dies, it is broken off into pellets. The ideal fuel pellet is a 1/2 inch diameter with a length of 1 to 1.5 inches, with a very low moisture content and little to no fine dirt, sand, or metal. The pelletized fuel will provide for more consistent and complete gasification in the lower chamber of the thermal combustor. As the compressed fuel is ejected from the densifier equipment, it is then conveyed up and over to a larger storage area we call a day bin. The day bin collects the densified fuel pellets and stores enough to provide a consistent feed to the thermal combustors, even when there are brief interruptions upline. From the day bin, we convey the fuel pellets to the top of the thermal combustor. In this Colonia Veneta installation, we configured the day bin to feed the fuel pellets to each of 2 thermal combustors. Once the fuel is conveyed to the top of the thermal combustor, it is fed into a hopper that supplies 3 rotary feeders. The feeders are the green boxes on top of the thermal combustor. These rotary feeders distribute equal amounts of the fuel onto the gasification belt inside the first chamber of the thermal combustor. Looking down into a rotary feeder, you can see that the fuel is evenly metered into the thermal combustor. It enters through an airlock that keeps the gases inside the gasification chamber. Each of the 3 rotary feeders is separately controlled to balance the fuel evenly across the gasification belt. By evenly distributing the fuel, the operator can get a consistent volume of fuel for the most efficient gasification. This produces greater amounts of fuel gas, which is later combusted to create heat. With minor modifications, we can change these rotary feeders to process another type of hydrocarbon waste. Here's a side view of the 3 rotary feeders on the second of the 2 thermal combustors in this installation. And here's a bird's eye view of one of the thermal combustor's fire tubes before the outer skin is applied. You can see the fire tube connected to the boiler, which is the light green box. The fuel gas we created in the gasification chamber is burned in the fire tube. The heat from the tube is then delivered to the boiler to generate high-pressure steam. Begin producing fuel gas. The spent fuel is then dropped into an internal water trough at the back wall of the inside of the thermal combustor. At the bottom of the water trough is a screw conveyor that moves the bottom ash from inside the thermal combustor to the outside drag chain system. The spent fuel, or bottom ash, is conveyed up on an incline to remove the majority of water. The ash is then deposited into a movable hopper for removal from the site. This bottom ash material is typically inert and toxic-free. That makes it ideal for use as fillers for road base or similar applications. The amount of ash you see coming off the drag chain system resulted from processing around 1.5 tons of refuse-derived fuel per hour. You can see that the fuel is evenly metered into the thermal combustor. It enters through an airlock that keeps the gases inside the gasification chamber. The fuel gas is contained and then combusted in the fire tube to generate high-temperature heat that is carried through the fire tube into the boiler. Looking through the thermal combustor's view window, you can see the glow from the gasification process. By partially burning the waste fuel material, we generate large amounts of fuel gas. Temperatures in this chamber reach 2300 to 2400 degrees Fahrenheit. The fuel gas we create then moves into the fire tube for combustion. Combustion in the fire tube further raises the heat up to 2600 to 3000 degrees Fahrenheit. The fire tube then introduces heat into the boiler. The boiler converts the heat into high-temperature steam. We then pipe the superheated steam over to the gray collection tank. From there, we send it into the steam turbine, which spins the generator and converts it into electricity. The electricity then goes to the transformer and switching gear. Industrial waste, biomass, or plastic waste. What's more, you can quickly change from one type of waste stream into another. Saleable byproducts. It is so efficient that it exceeds EPA and European Union standards. That means you can use it anywhere in the world.